What's up, you math maniacs? This is section 1.4, sketching graphs and comparing functions. Actually, it's a terrible name for what I really want to do with this section. I don't want to be sketching graphs, nor do I want to be comparing functions. What I really want to talk about is increasing, decreasing, and constant. So if you imagine yourself on a roller coaster, like if you are actually skiing down this mountain, if you're going down this roller coaster track right here, you're going down, reading from left to right, you're going down, 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 up, 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 down, 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 up, 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 and having that imagination is kind of fun to thinking about increasing, decreasing, and constant. So when we're describing whether or not a function is increasing, decreasing, or constant, we're going to use the x values, not the y values. And we're going to use intervals like 3, 4, not individual values like x equals 3. We're reading from left to right, as I already said, and those intervals can be opened or closed. Your choice. Both are kind of acceptable, and that's fine. So label these intervals as increasing or decreasing. Looking at the x values, remember, these are not individual points on a graph. Like, these are not location xy coordinates. No, these are intervals of x values. So as x goes from negative infinity all the way up to negative 1, what is happening to the graph? Well, from negative infinity all the way up to negative 1, it looks like it's decreasing. It's this blue section right here. You see the x value is negative 1. So we can say that this is decreasing. Go ahead and make sure you're writing that down. And then increasing, negative 1 to 1.75. Here, the x value of negative 1 to the x value of positive 1.75. This whole section right here is increasing. And then the section from when x is equal to 1.75 up through 3, that interval, 1.75 to 3, this is decreasing. Like I said, if you're on a roller coaster, or if you're skiing down this hill, it goes down, 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 reading from left to right, down, 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 up, 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 down, 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 up, 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 up. So decreasing, increasing, decreasing, increasing. Again, the interval from 3, to infinity, including 3, you start here and you go to positive infinity, and you can see that that is increasing. Here, let's take a look at this really squiggly function. It is a function. It is, and let's see, it's going up and down and up and down and up and down. It's actually never constant. It's never flatlining. The increasing intervals would be from negative 5, x equals negative 5, up to x equals negative 3. This portion right here is represented is an increasing interval from negative 5 to negative 3. The next increasing interval is from negative 1 to positive 1. The next increasing interval is from 3 to 5. So you can see that these are 3 different intervals, 3 different sections of the graph where it's increasing as you read from left to right. The decreasing intervals are, here's one, from x equals 1 to x equals positive 3. This interval is decreasing. And I'm wondering if you can figure out what goes underneath this red dot from negative 3 to where is the decreasing interval stop? It starts at negative 3, and where does it end? All right, let's do so. That's like basically all the new stuff I want to talk about today, and let's review some of the old stuff. The domain. Let's look at the blue and green curve above first. Domain of this curve is all real numbers. If you were to collect all the x values of all the points on this entire graph, it would be all real numbers. The entire number line is represented. If you give me any x value, I can tell you what the y value is for that function. What's the range? Well, if you collect all the y values, notice there are plenty of y values that are not represented here in that collection. The graph has up, up, end behavior, so it'll go up to positive infinity. There is no highest y value. It keeps on going. But it does have a lowest y value. The minimum is negative 3.2 right here. That's the lowest y value. So you can say that the range is all numbers from negative 3.2, that's the lowest, infinity, parentheses. And we're including negative 3.2, and typically we don't include infinity. We just use parentheses. Is it continuous? Yes. You could draw the whole thing with a single stroke of your pencil and not have to lift it up because you had a jump or a break or something like that. Does it pass the is it 1-to-1? Does it pass the horizontal line test? The answer is no. This answer is, I should change this. It's actually yes over here. It should be no. All right. You could draw a horizontal line and touch more than one point on the curve. Like the x-axis, for example, touches it 1, 2, 3 times. And therefore, it is not 1-to-1. Extrema. It has a minimum of -3.2 at x equals -1, and it has a relative maximum of 0.439 at x equals 1.75. If you just focus in right here, you could fool yourself into thinking that it's the highest value in a little tiny zoomed in area, but if you look globally, it actually it's not the highest value. So it's just a relative maximum. It also has a relative min of 0 at x equals 3 right here. It's a relative minimum. It actually, and that's good. The end behavior is up, up. Verbally, you could say as x goes to negative infinity, or as x approaches negative infinity, the y value approaches positive infinity. And as x approaches positive infinity here, the y value will go approach positive infinity as well. Is there any symmetry? Nope, no symmetry on this. Next, let's look at this squiggly curve over here. If you were going to say collect all the x values to figure out what is the domain, then, and assuming that it keeps on squiggling in the same way, as far to the left or as far to the right as you could go or want to go, then yes, all real numbers are in the domain. Every x value is associated with a y value. There's no explit. Every x value is represented in the domain. What about the range? Well, actually, it's a very limited range. It doesn't go any higher than +1, doesn't go any lower than -1. It just stays, it squiggles within this narrow region, very close to the x-axis. So the range is very small. It only goes from -1, +1. Is it continuous? Yes, it is continuous. You could draw the whole thing with one swoop of your pencil and wouldn't have to lift it up and jump somewhere else. Does it pass the 1-to-1? Is it 1-to-1? Does it pass the horizontal line test? No, it does not. It definitely does not. You draw a horizontal line right through the middle, and it intersects it definitely more than once. Like it even intersects it an infinite number of times. What is the minimum value? The minimum value is -1. That's as low as it goes. And where does it happen? Well, it actually occurs multiple times. It happens at -5 and -1 and +3. And you keep going, +7, +11. It's an infinite list of minimums, minimum locations. And then what about the x? What about the maximum? Well, yeah, it does have a maximum value of 1, maximum value of 1, maximum value of 1, and it occurs many, many times. -3, +1, +5. What's the end behavior? Well, it doesn't really apply here because it's not going to positive infinity, it just kind of squiggles. So we're not really going to answer what the end behavior is. This does have some very interesting symmetry. If you put your finger right here and you spin the paper around 180 degrees, then you'll get an exact copy of the graph. We call that, we say that it is an odd function because it has rotational symmetry about the origin. All right, folks, get out those calculators. Here we go. Hey everybody, it's time for some inspired calculator work. So pause the video, go grab the calculator. And now that you've got it, here it is. Let's get started. All right, we're on the home screen. Go to B graph, and I'm going to type in x raised to the third power, exit the exponent, minus x, enter. There's that beautiful curve. Love it. Menu. I want to show you what trace does. I'm going to go down to 5 trace. Enter. And yeah, let's graph the trace. And you can see as we move the arrows left and right, as we increase or decrease the x values, you can see that we've got this these numbers down here. It tells you where it is, and it traces the graph. Kind of handy to have. Goes all the way up to the top, down to the bottom, and then back up again. Isn't that fun? tab, F2. Let's type in another function. 0.5x plus 3. Enter. Ooh, now we've got a function 1, function 2. Let's do menu, 5 trace, and 1 graph trace. Now, using the left-right arrows, we go up and down. Using the up-down arrows, we select. So, up to function 1, down to function 2. Up to function 1, down to function 2. Left-right along the graph, increasing or decreasing the x values. Menu. Down to trace. No, down to 6, analyze graph. And then let's find the intersection. For intersection. It just can't find the intersection by itself. It needs a little bit of extra help. It needs to know, like, where exactly should I be looking? Left bound, lower bound, upper bound. And in between the two, it has been able to find that intersection, point of intersection. Let's clear it. Control, delete, enter. Let's just clean up some stuff. Go up to function 1, Control, delete to clear that also. Looks really nice. Let's rezoom things a bit. Menu, 4 window zoom, and 5 zoom standard. Now everything is great. On to get back to the home screen. That's it.